All right, welcome everybody. There's a really fun pillar sitting right in front of me, but that's okay. I'll just scan the room this way and that. It's really nice to see you all. You'll all know who I am because I'm very awkwardly on that video from lunch. I'm Andrew Reddie, an associate professor of public policy at the Goldman School at UC Berkeley, and it's my privilege to moderate this panel. Thank you, Leroy, Nico, and Joe for pulling all of us together. We have a mixed panel with both virtual presenters and in the room presenters, so we will do our very best. I have changed the order slightly so that we have everybody speaking on Zoom first, which will hopefully make it work. We'll see though, given that we're missing one of our guest speakers. And then I'll turn the floor over to our speakers in the room. I'll give a brief round of introductions now. The full bios for all of our panelists are in the read aheads. But just very briefly, we're joined by Professor Robin Murphy, Raytheon Professor of Computer Science and Engineering. We're joined by Meredith Lee, Chief Technical Advisor at the University of California, Berkeley for the College of Computing, Data Science, and Society. We're joined by Simone Fobi, Applied Research Scientist in the Microsoft AI for Good Research Lab. And Nick Merrill, Director of the Internet Atlas Project at the University of California, Berkeley Center for Long-Term Cybersecurity. And finally, we're joined by Rodrigo Madanes. Yeah, gotten there? Okay. Who I think has the best title that I've ever seen and that I want, Global AI Leader at Ernst & Young. So with that, I'll turn the floor over to Robin to share her screen and presentation. Robin, each of us have 8 minutes to kind of give a spiel, and we'll do our best to stay on time. And so with that, over to you.
Well, very good. Can you hear me?
Yes, indeed.
Oh, great, because I'm getting the little rainbow spinning wheel of death, which seems appropriate for someone named Murphy, right? Murphy's Law attached. Well, I specialize in artificial intelligence for drones for disasters. I've been working in disasters since 1995 with drones, since 2005 with Hurricane Katrina, the very first use. I've deployed 19 major disasters with drones, and the big takeaway is love AI, love AI. So frustrated that the wonderful AI and data science that we're getting isn't getting into the hands of the responders as much as it should be. And there are two reasons for that. One is that the data sets for the computer vision and machine learning part are just not ideal. They're often collected or annotated for problems that nobody in the field cares about, or they're staged incorrectly. There's nothing. I just want to assure you that missing people don't wear bright orange T-shirts and stand in the middle of a meadow. So pretty there. But the second one that I think is the killer that we can all fix is the fact that all of our solutions tend to be in the cloud, not in the edge computing. And so we've seen this pattern starting with Hurricane Harvey, which was, when you're having over 200 flights over multiple days, but most recently at Hurricane Ian. So can you see the chart? Or have we frozen?
Yeah, we see it.
Oh, great, because I'm frozen over here on my side. We're just going blind. All right, so it's a big chart. So look at the chart on the left. And what that's doing is the amount of the blue bars going up, more means more gigabytes per hour of imagery coming in from the drone teams. Okay, so this is for the state of Florida, Hurricane Ian. They're trying to get that data as fast as they can. So first day, we don't really have any connectivity, so we're just manually taking SD cards over. Day two, we're getting a little bit more. The green line, the optimistic, the best we ever saw was more the yellow line, where it's really roughly only about half the bandwidth that you would get from a crappy home wireless system. On day three, as is at 72 hours, we're shifting from immediate tactical use of drones for tactical rapid recon to more imagery, more intensive map imagery, and then look at what happens. We don't get a huge increase in bandwidth, but we get a huge increase in the data that needs to be pushed through the pipe. And then you see it begin to go down after day 4. Now, if you look over at the right one, I've kind of rotated it to try to look more like a pipe and sort of a Tetris type of thing. And the point there is to see that the blue is that The dark blue is what we're getting coming as data managers, as drone managers, trying to get that data in there versus what we're able to push out. And it's not only does it not match the bandwidth, we get into a hellacious backlog of data. And of course, there's so many ways to work on this: edge computing, prioritization, things like that. But I think that's one of the big barriers for preventing all the excellent work that's being done in data science, and to get that into the field, into the hands of the responders. So with that, look forward to hearing from everybody else. I'm trying to stop share honest.
Perfect. Thanks so much, Robin. I'm not seeing our next Zoom participant in the room, so why don't I turn the floor over now to Meredith. And Meredith, I will share your slide deck here for you. Hopefully. Let's see here. And slideshow.
No, we don't want to just share. Just show it as a slideshow.
Oh, you showed a slideshow?
Yeah.
Okay. No problem.
Thank you, Andrew, and thanks to Nico, Joe, and Leroy for the invitation for this first ever UC Disaster Resilience Day. It's about time, right? So I have been working on various aspects of disaster resilience, data-informed decision-making, particularly in a crisis scenario for, Andrew, I'm a little bit upset that you made me count this, but 23 years. It actually started just down the road at UC Davis at a time when authorities were shutting down beaches because of health concerns, and there was an acute need for information about potential water contamination sources. I then spent about a decade at Stanford working across electrical engineering, medicine, and biology to design and develop real-time medical devices for diagnostics. And then you would think I would have seen the pattern by the time I went to DC, but I was trying to keep an open mind about how to contribute. And I was at DHS, Department of Homeland Security, Science and Technology Directorate, which includes FEMA. And I ended up leading a great interagency collaborative initiative called the White House Innovation for Disaster Response and Recovery Initiative under President Obama. And with that team of dedicated emergency managers, researchers, and so many policymakers, I was just so grateful to be able to work with folks who would roll up their sleeves and not only participate in the big milestone community engagement events and workshops, but also day in, day out, weekly calls. That was a time when there wasn't a lot of video chat, and it wasn't so easy to get numbers like 1,500 people participating. And so the comms folks felt that that was a headline in and of itself, that we had 1,500 people joining, given that the White House didn't have great Wi-Fi back then. There were literally articles about how bad the Wi-Fi was at the White House. And that initiative, for those who aren't familiar, grew out of the wake of Hurricane Sandy, really to empower first responders, impacted community members, researchers with information and resources that they could actually use. And that was something where there's a lot of articles you can read online, but I wanted to take two takeaways that I think might be helpful for the Disaster Resilience Network and highlight those. The first is really the power of workshops. Much like we're breaking into rooms here and having these roundtable discussions, having honest assessments and conversations, we did that to look at everything from the value of data to social media being new back then, to user-centered design, predictive analytics. And it allowed us to start to build a fluency and to understand different perspectives, where we had shared pain points, and what we might be able to accomplish together that would be better than what we could do individually. The second theme that I think might be helpful for DRN is really in the power of public commitment. We hosted a number of convenings over the months and years of the initiative where we were able to lift up examples of individuals and groups who were pulling together resources, who were bringing together people to collaborate and break out of those silos of excellence, as one of our morning speakers noticed. And so that allowed us to start to build a culture of partnership and to think about the mechanisms, the incentives to keep that going, so it wouldn't just be a one-off thing that led to a report that was a PDF that nobody ever looked at again after it was released. DJ Patil, who was the first US chief data scientist and recently joined Berkeley as the College of Computing, Data Science and Society's inaugural Dean Senior Fellow, he likes to say, data science is a team sport. And if it's a team sport, what's the team win? What are we looking to do together? One example that still brings me that flutter in the heart was when I was there in DC, I learned about the Finder project. This is a collaboration across DHS Science and Technology Directorate and NASA Jet Propulsion Laboratory, where at the time people were prototyping and testing this radar technology that was aiming to detect heartbeats under 30 feet of rubble, 200 feet away. The 7.8 magnitude earthquake hit Nepal in April 2015. And that ended up being one of the worst disasters that year. I think a UN report noted about 8 million people impacted. And somebody somewhere signed off on using that technology before all the check boxes were done. And it got flown over to Nepal, and it was deployed in search and rescue. We were able to find 4 men who had been buried for days, trapped in 2 separate buildings. And I just remember thinking, wow, that's super inspirational. Somebody took a risk to send that over before it was quote unquote ready. And what might we be able to learn from that moving forward for other emerging technologies? It was part of a broader conversation on how to really harness the benefit of tech and data. And as someone mentioned this morning, how to map the pathways to success. So one of the strategies that we used in the Obama administration for mapping those paths to success was really to build a bigger tent, whether that was with the architects of data.gov, with the National Science and Technology Councils. We tried to make it so that we had alignment from this big vision for impact and the scaffolding and all of the pieces underneath the foundation of data and tools. And importantly, at the core of that infrastructure was humans, really the community of practice, the people who would roll up their sleeves. And as this image shows, whether it was over a weekend or every day over many weeks and months and years, they would design and build and listen to folks like the New York City Office of Emergency Management, listen to groups like the Red Hook Initiative, community members, neighbors, and we would co-create and test our assumptions, try and try again. I did not know about the DREAM acronym, but here you can see on the Post-it, somebody shortened the process and said, you know what, we're really dreaming, seeing, and doing. We're looking at what's possible, imagining that art of the possible, seeing it come together before our eyes, and then committing to actually do the work to make it stick in real life. And with that community comes human perspective and purpose. Personally, I think we would be completely lost without that. data on its own without human perspective and purpose is just not sufficient for this field or many others. And so that's a theme that we see when we're collaborating with open platforms. It's a theme that we hope that students, those are all students, it's filled to the rafters. We hope that students in our Foundations of Data Science class, in the Human Context and Ethics classes at Berkeley, with our partners at community colleges, CSUs and UCs, and the hundreds of data science instructors who we convene annually for workshops, we hope that that comes through so that students of all backgrounds, learners, can really think about that impact that they can have in a space that's as important as disaster resilience.
Yeah, of course. And Simone, over to you, and I'll flip us over.
Hi everyone, I'm Simone Fobi, and I'm part of Microsoft's AI for Good Research Lab out in Seattle. And today I really want to talk about how we've applied data science to some aspects of disaster response and how we approach partnership to making sure that the work is impactful. So our key partners, at least some of our key partners, are Planet on the imagery side, and I'll explain why we use imagery, and the American Red Cross that helps us utilize these outputs. So before I go into work, I'm sure everyone is already familiar with how disaster resilience is defined, but from our lens, some key things pop out. One is the ability to recover in a timely and efficient manner. And that's how we try to apply our data science mental models when we develop solutions. Disaster response and recovery can cover multiple topics, dimensions such as warning, evacuation, search and rescue, providing immediate assistance, many more. On our end, we focus mainly on assessing damage after a disaster has occurred, and that is done by applying computer science techniques, methodologies to remote sense imagery as shown on the right. Before going into how we go about it, just for some context, one of our key partners or strategic partners is the American Red Cross. And for damage assessment, they utilize outputs from building damage assessment to aid with both response and recovery. And that can span from anywhere between 2 weeks and 6 months. And our objective is, can we empower them to take action sooner than those 2-week periods? So what do we exactly try to do? We start off with some high-resolution imagery after a disaster has occurred. And what we're trying to do at the end is to have some building-level assessment of damage. On the red polygons show the proportion of damage that we estimate on a building, and that's what we hand over to our partners so that they can take action given these outputs. In reality, how we approach the work is that stepping back, we're really trying to design a workflow that works well across multiple disasters. We can get results to our partners as quickly as possible, and we can repeat it across different geographies, different disasters with quicker modeling time. So what that might mean is that it's not necessarily one model that we train and then just do transfer learning. It's really about the workflow and how we do damage assessment. So like I mentioned, timing is of the essence. If our partners are evaluating damage at the building level, one way to go about it is to have human labelers look at every building and determine whether or not the building is damaged. For us, we see the value of data science, of AI coming in as being able to do that quicker and assessing all the buildings in the landscape of interest. So for some context of some of what we've done this year, we did some work in the US for Rolling Fork, Maui wildfires, Hurricane Idalia. We did some work in flooding in Greece, the earthquakes in Morocco and Turkey. And the reason I wanted to show this diversity is our team works on different types of disasters. Like I mentioned, not necessarily with one model, but with a workflow on how to adapt across multiple disaster efforts. So in the case of Maui, just to contextualize this workflow, we start off with some imagery. We get some polygons, and those polygons might contain background, some undamaged buildings and some damaged buildings. What we're trying to do in our workflow is to support a low labeling effort so that getting labels to train our models is not exhaustively taxing for the stakeholders. We also perform some validation while after we've trained, and in this case, we had very good performance in general. And from the time we were able to receive imagery from our partner Planet, it took us about 4 hours to do the workflow, assess all of Maui, and get those results back out to our partners. So one output was a visualizer where the partner can see where the damage has occurred with pre and post imagery. And some of the feedback that we got was that this work was able to improve the response time significantly, up to 5x than they would have done without it. So for us, that reinforced the need to have partners that can take up the work and be able to use it. And that also influences how we design the workflow. That being said, there's still some things, having gone through the disaster assessment or damage assessment workflow, that stand out to us from a data science perspective. One is domain generalization. So we noticed that having a singular world model on different types of disasters, different image modalities that include resolution, illumination conditions, it's really difficult. And the science is not there just yet. And that's an opportunity that research can possibly push towards, on how do we have multimodal models, how do we have a standardized set of data sets to test the scientific methods. So right now we have a lot of data coming from some of the regions I've shown, but in, let's say, sub-Saharan Africa, where flooding may have occurred, there might not be readily available data there. How do we standardize data sets so that we can evaluate the performance? We also think that metrics are important, especially metrics for the stakeholders. Yes, there are data science metrics like precision recall, but what does that actually translate to the stakeholders? Are they interested in evaluating at the building level, or does it make sense to look at it at a census block level? What do they want to do with the outputs? So again, working with strategic partners to us is important, and we think that the science should also evolve to supporting defining what metrics are relevant under different damage scenarios and for different communities. Finally, I think all the panelists have echoed strongly collaboration. I think that's one principle we stand on, is that we look for stakeholders to work with. We're open to working with diverse stakeholders, as that informs how we develop the models that we make. I think I'll stop here for now, and thanks for the opportunity.
And Rodrigo, I get to turn the floor over to you.
I've been wondering whether I should just pass, given that I spoke this morning, and that I had a couple of thoughts that I wanted to share that, of course, I didn't cover in the morning around AI. I think there's some interest in this group around Gen AI in particular, so I figured I'd share those. And they're not typically talked about in the press, which is surprising. One of the things that I think, in terms of opportunity or positive about Gen AI, that is not normally discussed except in research circles, is the velocity at which this technology is getting better. There's some research papers out there, so I'll elevate for a second. We have used as a heuristic in terms of the power of these AI models. AI models is the phrase we use to call this compute capabilities. We have tended to use the size of the model as a heuristic of like how powerful it is. So we call it billions of parameters. And there's different organizations building these models. And they've charted over the last 8 years sort of how fast are these models getting bigger. And I think all of us know Moore's law, right, which is roughly double the capacity in about 18 months. Well, it turns out the size of the models that are being built are going at about 10 times Moore's law. So if you plot Moore's law like this, the size of the models goes like this. Now, that's impressive as a feat. It's also a bit scary in terms of not what Gen AI can do today, but in 2 years. I'm not saying in 10, I'm saying like in 2 years, it is going to be crazy the power that these models will have. So we should be skating to where the ice puck will be, if you will, as opposed to assuming that today's world and today's technology is what we need to adapt to. So that was one idea. Like, this is an interesting one. People don't, like, I'm closer to it and I see that. I go like, do people realize how fast this is moving? Now, I think it's a big opportunity in that one thing that we tend to forget is how useful this is to many people. And there's some nice projects, like there's a project called Be My Eyes, where you can, I think many of you might have seen it, where it can detect images, and if you're blind, it'll tell you what's out there, right? And you can ask it questions. And there's a lot of studies where they A/B test people with these generative AI tools and people without them, and the sort of grades or capabilities are top 15, 20%. So compared to average, which gives you the sense that we could probably increase the performance or productivity of all of us if we learn how to use these tools. So there's a lot of good. I don't have to remind you, Andrew, about the potential dangers of such powerful tools. People are already talking about what are we going to do when we get 50x or 100x the amount of content out there. If we can generate it so easily, it's going to flood all our systems, and how do we detect that and manage that noise? So there's all kinds of ways in which we need to put some order to that. I don't have much more. I did have one. I was at a conference this week, and there were a few questions which I thought were very interesting that I captured, and I wanted to sort of share with this group because I thought they were relevant. And the questions they were posing, this is an AI conference for business folks mostly, was probably the right frame of mind people should be asking is not what does it do, but what can I use it for? That's a good question. Like people want to know, what can I use it for? The other one is, what should I be doing now? That was a good question. And the one that was most provoking, that I think it's fun for this group, was somebody made the statement that car companies today are all software companies, meaning the industry has shifted so much that car companies are software companies. So the provocative question for this group is, what if disaster prevention and recovery becomes a software industry, and what would that mean in terms of what needs to change organizationally, the investment in resources, the tooling? So I thought those were provocative questions, which I figured would be fun to share. That's all.
That's great.
Thank you.
So much. All right, I am not seeing Nick, so why don't we just get started with some Q&A. Rodrigo, really like that point on the use cases. I have to say that a lot in the AI conversations, right? Doesn't matter how many layers are out to your neural network, right? That's what it does, and it's the use cases we have to be thinking about in terms of the problems. You've heard a lot there, and I think one of the things I really like about these presentations is you saw technology both as a unit of analysis, I think, to be measured in Robin's presentation, and then also technology as a method to try to do disaster resilience and disaster recovery better. And ultimately, I think there's a couple of things that stand out there that are incredibly exciting. I'm of course excited about all the students that Meredith showing up to think about these problems, right? Obviously, the next generation is a big part of the puzzle, And it's something that obviously this room should be thinking very hard about. And I think it's what the UC online courses for this, project have also been really focused on as well. Because I think that all of the tools individually that we're talking about here will be improved and changed categorically by that next generation of students that are coming into the field. And then another piece of it is the public-private partnership piece. So actually, Simone's group actually demonstrates one of the things that Rodrigo just brought up at the end there around, well, what does it look like for disaster recovery to be a software space? I would argue that, Simone, you're kind of doing it, right? And it's becoming that software space. And of course, we have to think about, well, you've got private sector actors with private sector interests, right? What are the commercial sides to the service delivery that are being provided pro bono alongside NGOs? But I think that's the kind of ecosystem we're in. And I think for me, like, we're here. And we're already kind of thinking about these as software problems. And, ultimately, I think it's very exciting to think about all of these tools and technologies that we now have at our disposal and bringing it into this space. So before I open up the floor to all of you, I'm going to abuse being a moderator for a second. And I'm just wondering if we can go down the line and think about whether you think that technology applied to these use cases around disasters, whether it's a story primarily about taking the low-hanging fruit of the technology that we have available and applying it to disaster response, recovery, resilience, or whether you think specifically there are the latest and greatest technologies that we need to push for in relation to these use cases. So put another way, does it require lots of innovation to actually get a step change in disaster response and recovery with regards to tools, or do we have plenty of things inside of our stable that we can be doing to make this stuff better today? So perhaps, Robin, if you were able to hear.
Absolutely. Well, as a responder, we're not getting it. Okay. Okay. Well, anyway, so as a responder in the field, we need the exploitation of this technology, seeing that gap, in what's possible to get shown in a laboratory or a one-off situation and never gets to everybody else, takes it to the next disaster. And that's because it's hard work. It's not work. It's not the master's students. They don't know how to write. There's a lot of interfaces, things to it, that usability and trust. And so that's hard for us as researchers who want to do the next great thing, to go back and have to do all that. Somebody has to do all that painstaking work. And that's one of the problems with earlier talks in the morning. We're talking about how there's not a lot of incentive for private companies. There's no business case for it. And I think that's where we're seeing a barrier.
Yeah, good. I like that. Rodrigo, perhaps you can also reflect on that as well from your perch, kind of being that liaison between the public and private sector for a lot of this stuff. Meredith, I'll turn the floor over to you.
Yeah, there's a whole spectrum, and there's this valley of death when you try to go from the proof of concept to actually translating, operating at scale, deploying in various contexts. And I think I do have some hope that if we ground our training and education and even, research, imagine that, if it was grounded in how these might be used and that context, then maybe we could come up with things that actually will survive and will go past this model of, well, I built this in the lab, I'm going to throw it over the fence, it's going to drop off the truck, and it just doesn't work. I come from a hardware background. For software, you could throw some things, but then there's like a whole nother level of like, how do you make that robust, and how are you building in the measures to understand performance over time?
Yeah, shameless plug. I'm also a cybersecurity researcher. The software problem there, where we actually do throw things over into the market before they're actually ready, has fairly deleterious consequences. Yeah, very good. Simone, over to you.
I think there are two things that stand out to me. One is when one is looking at the newest technologies, it's still going to be trained with, or I'm assuming it's still going to be trained with the data that exists out there. And if that data is not necessarily reflective of the landscapes where new disasters will occur, or the types of disasters that we're seeing, then the real world impact is not as strong. That being said, one thing from our observation is that you can't necessarily take something out of the box and it works immediately for the damage, at least for the damage assessment work that we do. You still need to understand how damage occurs or presents itself in a specific locale, even though it might be the same thing. Maybe it's a hurricane in Florida and a hurricane somewhere else. It might look different just because of how the built environment is. So that's where if you take something out of the box, it won't work. You still have to tune it to the problems that are on the ground.
Yeah, it was interesting. During your presentation, it was still fairly noticeable that it's a fairly high touch problem set, right? Like you're talking about human-oriented labeling, et cetera. Obviously, there's efficiencies that you can eventually imagine with non-human labeling tech, but yeah, I think that's a really good point. And of course, context always matter. Rodrigo, over to you.
I don't know if I have. I mean, my sense that if the original question was, I'll do this. If we still need to do a lot of innovation to get there, or there's already plenty of tools to work from, I would say there's plenty of tools to work from. They just need to be cobbled together to solve the use cases that are relevant. I wouldn't dither trying to get. I mean, I'm sure there are situations where you can do innovation, but I don't think we're at the stage of, we're far away from having a good set of tools we can cobble together.
Very good. So Leroy, Joe, and Nico, we need more than an hour, I think is probably the point, right? To try to parse some of that out. Very good.
I'll give you an example. I
Yep.
was talking to a friend of mine who's a professor at Berkeley Business, and he worked with India, and he was saying, hey, GPT-4, should we be using it in certain places for health work in India? Because, it's high quality. And I was trying to think about it with him. It's like, look, it's not going to beat a great doctor. But then again, you have segments of people in certain situations where you have doctors, you have medical workers, which are unlicensed, very low education, and then you have like villages where there are not even medical workers. There are certainly situations where having access to good medical knowledge that will beat whatever knowledge is there, there's probably some use that can be deployed there. Like, sure, there are, regulatory and other issues that need to be looked at, but there's probably some good that should be explored.
Yeah, that's a really important point. Like, what's the bar, right?
Yeah.
With regards to present case and versus future case. Yeah, I think that's something in all these places and cases. You have to think about the application technology, right? Like, what's the base case? And we've seen a variety of different kind of scenarios explored throughout the entire day, where you can imagine these being very transformative, right, impacts, and then other cases where only on the margins. So let me turn the floor over to. Go for it, Robin. Yeah.
So one of the dangers, though, we see in public safety emergency management sorts of things is that demographic, that socio-technical organization is very conservative. So the problem we've seen, and I've lived long enough to see a couple of cycles, if you screw up, if you give them a technology that doesn't work, it's not reliable, or it's too hard to use, then they walk away from it. You're stuck for about 5 to 7 years before you can reintroduce it. So I think that also brings, as we use terms like cobble together and what are toolkits and everything, that we've got to be very careful on how we approach these use cases, because this is a group that is publicly accountable. They have to explain why they made a decision, and they're very distrustful of hype.
Yeah, absolutely. I mean, so I'll crypt together the notes of Nick Merrill, who was supposed to join us but couldn't make the Zoom work on his end. I mean, one of the things that he was pointing out is actually some of the technologies that we rely on day to day actually introduce new vulnerabilities and risks, right, from a societal perspective. So if you are building a society that's relying on an internet connection for the provision of fairly basic services, oops, right, during both, hazards natural and then hazards man-made. And so that was one of the things that he was going to talk to regarding our internet backbone. So yeah, that extends Robin's point. Ultimately you have to be careful about what you're introducing all around. So I'll open the floor up to all of you with regards to questions. I see one right here in the front. Yeah. And I'll come to Joe. Yeah, perfect.
Oh, just building on Robin's comment. So where should we be putting our energies, given the radical changes, the rapid advancement in technology, the role of artificial intelligence, the huge gap between the complexity of the existing technologies and ordinary users and stakeholders? What should we be doing looking out 2, 3, 5 years from now?
Great, you stole my last question. Nicely done. Let's just go down the line. Rodrigo, perhaps we can start with you.
I think one of the questions is, are we talking about? I took Robin's point, and I agree that in the U.S. it's very a lot of accountability, but I'm sure there are some places in the world where doing a lot of good, like you have a different balance of judgment in terms of like you said, Andrew, like it's much higher than the current bar. So I think it's what should we be doing where, because I think there's very different contexts in the world of what's needed.
Perfect. Simone, as you look about think about where your team ought to go next, right? Thinking 2 years out, 5 years out, what are the technologies that you want to see implemented?
I think right now we're very much in the space of response, but I think what would be interesting for our team is to go into risk assessment, which is harder, but at least I think the response space sets out some foundational work for us to be able to look at potentially temporal imagery to see damage over time, to understand risk of areas. And so I think for us, that would be maybe the next direction. Now, maybe to the question of what tools would help us build resilient workflows or models. I don't want to commit to anything here, but our principles of working are to have the stakeholder upfront to understand what they want to use it for, where they see themselves operating in the next few years, what is important to them. And it's from that place that we try to build our technologies.
Fantastic. Thanks so much, Meredith.
I really appreciate that question, Rich. It's not surprising, having been able to meet and chat with Simone, that I completely agree on the risk assessment, completely agree on the user-centered design. We can't forget about data quality and just like the basics. And so I would actually put a vote in for critical thinking and context. And as I said, the human perspective and purpose. It's so easy to chase the shiny ball and like, oh my gosh, look what it can do. And then, oh my gosh, look what it can do. But like, we are humans. We have, use cases that are in desperate need, have been for decades, around disaster resilience. And let's make sure that we remember why we're here.
I love that. Yeah. Don't forget, garbage in, garbage out, right? Doesn't matter how neat your model is if the data that underlies it's bad. Yeah. Robin, do you want to take that question as well?
Sure. And what everybody else has said, right, totally amplify that. Let me go from a slightly different direction. If you look at the models of how responders adopt technology, it looks to be influenced by 3 factors: risk to them, to their job, to what they're trying to do. Suitability is how well does the technology match what they're trying to do? Are there any hidden costs that are actually going to make the problem worse or make their time and effort larger that they can't accommodate? And the third one's availability. So for me, for the next 2 to 5 years, having great solutions that we, like with the data sets that are good data sets, that we have good test and evaluation that's there. But if we don't have a way to make it available, and I'm not talking about, you saw my numbers, there is no connectivity in the first 72 hours of a disaster when you need it most, even with Starlink and FirstNet and all that. It's not there. So saying, oh, well, just they'll download it and it's so easy to use, they'll be just in time and it'll just work perfect. That's not the way it's going to actually work. So how do we get that available? And particularly when we don't, as we see, is there's not necessarily a compelling private industry business model to make it happen. And so how do we do that as a government agency and as a people?
That's fantastic. I'm going to make life hard for our mic runner here. I'm going to take two at once. So we're going to go with Joe first, and then we'll come over to the back.
Thanks. It's amazing how the pace of impact assessment after a disaster has evolved. Mm-hmm. I moved to Indonesia 3 months before the tsunami and was all of a sudden leading the assessment of environmental damages. And we thought we did a Herculean job doing the assessment in 12 days because it used to take months, okay? But we had a deadline and we got it done in 12 days. Well, since then, countries that are affected by disasters are frustrated with that time horizon and they want instant results. And so there's been a big move to do rapid damage assessment. What we need to do is go beyond just the damage assessment. And this is the challenge, I think, to the data science community. We need 3 levels of assessment. We need the immediate impact, and that's where we're looking at buildings and infrastructure, private property, what's it going to cost to replace? But there's a second impact, and that's the loss, the economic loss, where a field is flooded and a farmer now has lost 1 or 2 seasons of harvest. And so there's a productivity loss, basically. So we need to speed up the calculation of that. And then the third thing we need to do is to assess how we build back better, how we build resilience into the recovery process. And we have to, at the same time, look at all of the cross-cutting impacts on gender, on governance, on vulnerable populations. So that analysis is needed. And then I just wanted to pick up on something that Rodrigo said, that, you know, there's an industry that develops around this stuff. And that industry has vested interests. So that becomes an impediment, I think, to technological innovation, where you've got a cluster of organizations, the UN, the World Bank, and the European Union, that like that post-disaster needs assessment approach that takes weeks to months. And there's another industry that's developed around the rapid assessment. And ultimately, I think it's what the client wants that's going to drive the market. So I think we're headed in the right direction with increasing the pace and the accuracy of the analysis.
So I want to jump in here because I think this is so great about the economic and the Build Back Better. And so that's already happening in parallel. A lot of what I'm hearing from here is everybody's thinking about the immediate recovery phase, not so much that first 3 to 1 week set of decisions where really on top of it, state or municipal emergency operations center is in fact looking at this going, oh, no, there's some problems here. And there's the Build Back Better. Can we build back? Are we going to be forced by the federal flooding act? They have to build back there. Do we put in levees? How do we mitigate it? An example of economic loss is that while at the Oso mudslides, huge mudslides, while there are simultaneously one group, one of the emergency support functions, ES9, is trying to recover the victims. Another group is this, ESF1's trying to rebuild the roads because everybody, turns out that took out the only road. Everybody else has got a 4-hour drive now to get into town, including some elderly people. How are you going to get them food and all that? And then another aspect, another group, I think it's 7, that was worried about the salmon fishing, that if the back flooding and the stuff wasn't corrected soon, they would lose an entire salmon season because, of course, it was happening at the worst possible time. So these things already come in, but notice nobody they're all little silos and different with these emergency support functions. And AI could do a lot better, I think, if we can help tie those in and help those connections be more apparent.
Very good. We also had a question right here. Yeah.
I'm Danielle Lee. I'm a public health nutritionist, and I'm a researcher at the Nutrition Policy Institute. And I'm really happy you brought up the data quality issue. So one thing we're facing right now is we actually do work with state agencies to get administrative data. And we try to do our best to analyze that data really quickly to rapidly respond to their requests. And we do mixed methods research. So we're getting quantitative data, and then we're also contacting individuals in some of these programs and talking to them. Yeah. And what we're finding is the data is actually quite messy that we're getting from these state agencies. And I really struggle to think about using these AI models on some of our state admin data. When we as researchers, as we're diving into their data, it's really not clean. Mm-hmm. And so I'm curious, like, as you're thinking about this and you're thinking about our state and federal data systems and possibly applying these AI technologies to them, what are we thinking about putting in place to prevent us from making uninformed decisions based off of AI models using poor data?
Great. You brought up Geigo, Meredith, so perhaps I'll come to you first and then maybe Simone.
You know, the first time we had a data quality roundtable at the White House, there were not many people. The second time it was a little bit better. So glad to hear that is a welcome thread of conversation. So this year happens to be the year of open science, for those who haven't realized it. It's actually across all federal agencies. And that isn't going to be enough. There needs to be, a pull from private sector, from startups, from academia, to build a culture of transparency, of not just the shiny result of look what worked and what we can do, but what's not working. Where is it so messy that, somebody spent, years trying to get something to work, but then they never necessarily shared those lessons. And that's something where it's going to take a community of practice that has, I think from my experience, it's going to take a community of practice that really has a safe space to share and to have that sandbox and discuss some of the hard questions about what might work short term, what actually makes sense long term, and do we have enough resources and people around anything that is a demo to actually make it more than just a demo.
Yes,
From my observation, I think the AI community is increasingly more aware of issues around data quality. There's some work that's been done on data sheets for data sets, I believe, where it's creating technical sheets for data sets so that researchers can understand things around quality purpose. There's also platforms or packages that are being developed around data trustworthiness, data quality. So these outputs are springing up more and more. And I think as either creators of the data sets or users of data sets, it's always worthwhile to first start off by investigating how trustworthy that data set is, where it works, what are the bounds of trustworthiness for that data set, and that can guide one's choice of ML methodologies.
It's actually, I love that somebody from a nutrition school brought this up, because one of the primary ways that the AI firms think that they're solving this problem, rightly or wrongly, are using system and model cards that are modeled on nutrition labels. And actually trying to get one another to red team one another's models, both in terms of, the challenge is that ultimately a lot of these AI firms, right, there's a commercial impetus that lies behind them. So they don't want to share everything, but they want to share enough that you think that it's trustworthy in terms of the outputs that you're generating on the training data side, and then also on the model and parameterization side. So we'll see, but that's the way that they're thinking about it now. But these conversations are all ongoing, and we're having them at an international level too, which I think is kind of neat. So I've stolen a couple of minutes extra, so why don't we end it here? Thank you all, panelists, Robin remotely, all three of you in the room. Thank you so much.